My name is Tim Pickens. I'm out here at Dynetics today, and we are with a great bunch of guys who are here helping us with a cool project this summer. They're with the NASA Academy. A guy named Frank Six over there at NASA runs an academy, and it basically brings some of the brightest folks in from all over the country, and it brings them in for real-world experiences in engineering and science. So these guys have various disciplines, from robotics to propulsion to GNC and whatnot. So basically, we've got some of these students here, and they've been working with us for the last 10 weeks. And we've asked these guys to lead a design effort to help us with our lander. We actually need some help with our guidance and control, testing those systems. And that can be really expensive, flying the full-up system. Plus, we're here on Earth, and the system's designed to fly in 1/6 gravity. So we've asked these guys to help us figure out a way to generate 1/6 gravity on Earth. And so let's see. Let's ask them who they are. Your name is?
I'm Peter Davison. I'll be senior next year at Princeton University.
Okay, and your role in this project is?
As the electronics and GNC guy.
Okay, cool. And your name is?
I'm Alan Bordelon. I'm a super senior at Louisiana State University, going for electrical and computer engineer, and I mainly handle the air bearing system.
My name is Tim Hahn. I'm a second year master's student up at the University of North Dakota, and I designed the plane that it runs on.
Cool.
I'm Evan Helmead. I'm a recent graduate of Purdue University, and I did systems integration. I was the team lead, and I also worked a lot on the structures.
My name is Josh Hooks. I'll be a senior at the University of Washington in Seattle. I'm focusing on mechanical engineering with a focus in mechatronics, and I was in charge of the propulsion system.
Cool, cool. Well, who can tell us what we're looking at? Because I think I know. We've worked a little bit together, but I've got some time to really dig into this, and I think these guys have really done a good job thinking this out really well, and I think they're giving us an affordable solution. So tell us what we can do with the IT. This is the IT. What do you call this?
We call this the X-Prize test bed. To give you a little bit of a kind of basis of what we're working off of, we came in the first week and we were basically told, come up with some sort of test plan for the lunar lander that Rocket City Space Pioneers is designing. And after going through system requirements and doing some research, figuring out what technology readiness level everything was at, all our different subsystems, our propulsion, GNC, electronic structures, we determined that the best option for Rocket City Space Pioneers was to go with a medium fidelity test bed so that we could prove the new technologies and all the subsystems integration. So we came up with this test bed, which features, basically we take our lander and we put it on its side on a slope at 10 degrees.
So this is 10-degree slope right here, okay.
Right. So that gives us lunar gravity acting this direction. So here are our main thrusters, which would normally be pointing down. They're now pointing to the side. So with this system, we can test, we have 2 translational degrees of freedom, and we can rotate. So we can test our propulsion system, the actual propulsion system that we'll be using on the final lunar lander. We can test our guidance algorithms such as obstacle avoidance and fine-tune landing, and we can also test structures such as our landing gear. We have a high-fidelity version landing gear. We can actually land this on a simulated lunar surface that we'll have.
Cool, cool. So we're looking at the 4 thrusters that would normally be at the bottom of our lander. So, and this has all the ability to do representative center of gravity and all those things that are important. And then this will have full lateral movement in this direction. So you'll learn a whole lot from this system. In fact, we'll learn it without having to crash anything, right?
Right.
So is that important?
Yeah.
I think it is, because we're all on a low-budget program here to get back to the moon. I think it's a great idea, and it gets away from all the coupled systems where we've got like tethers and things hanging and with masses and things, where you're always going to have some interesting coupling of the system that's tethering it, correct? So we get around all that. So, less the propulsion system. So what do you think it would take you to build just this framework with the air bearings, less the, say, the slope there? What are you guys estimating?
For cost-wise, you're looking at, that'll be about, what, $3,500 plus?
$3,500 less propulsion.
The air bearings are around 5,000 plus 3,500.
Okay.
For
So
structures.
under 10 grand for the structures.
Okay, cool. Well, in thrust we trust, right? We don't have thrust, we're just setting up against the lunar surface, which is where these feet will be. So, well, this is really a good idea, guys. And looks like the total system cost with everything is $150,000 for the GNC side of it.
That's if we can get some really good deals on our propulsion hardware.
Okay. Well, cool. So this is just a simple pressure fed. You got 4 peroxide thrusters, and these 2 thrusters
These
here.
are actually supposed to be the hydrogen peroxide kerosene bipropellant thrusters.
Okay.
With the ACS thrusters being just monoprop
Okay.
hydrogen peroxide.
Okay. Cool.
So that's-
So let me ask you this, guys. What's the biggest challenge of doing something like this? What worries you the most about what you're trying to do?
I'd say the propulsion.
Yes.
Is the propulsion going to be ready? 'Cause
The development of those thrusters.
So we always say it's those electron guys, electronics. So you think it'll be the fluid rocket guys?
Yeah, well, I mean, a lot of the electronic stuff is already, stuff that's been used before in Draper experiments, and, we tried to go what Rocket City Space Pioneers already has as much as possible. So, there are a few custom components, but they've been built before. There's nothing that's, brand new. The really only brand new thing is this propulsion system.
The other concern could possibly be no one has ever tried to use the air bearings we're using for this type of situation.
Okay.
Also, no one's ever tried to use air bearings on a slope.
Or with
So-
nitrogen that we know of.
But those things could be mitigated with pretty quickly, right?
Yeah,
We'll
with
do some
testing.
testing, find out if it'll work or not.
They are stated that they can operate up to 10 degrees slope. That's not a problem. The bigger issue is the heat from the thrusters, both radiated heat and heating up the concrete they're sitting on. And then there's a slight chance of peroxide compatibility if there's a spill. But talking with the warm gas guys, it's very off nominal case that any peroxide will land on the floor.
Is there any downside of moving these bearings a little bit forward of these thrusters?
The downside to that would
Not distributing the mass exactly
Yeah,
evenly.
you
like
don't
you
have a
want.
wide of a footprint, but the way it is, it's possible you could do that without any negative effects at
Okay,
all.
well, that might help that. Well, anyways, this is really cool. We're excited. These guys did this in 10 weeks, and now you guys are all going back to school.
Some of us.
You guys all graduating this year, the next year?
Yeah, he already graduated.
Evan's already graduated. I'll be working at Dynetics come September.
See there, I didn't know that. This is good. This is good. So this is a good experience for you.
My first officially saying yes.
Do you get to talk about what you're supporting, or is it a secret?
It's a secret.
Okay.
We don't even know yet.
Okay. Well, you guys hopefully have done some good networking. You've shown our technical team what your skills are. I've been really impressed, and I want to thank Frank Six for bringing these guys to us. It was a great experience for us. I think they've got some really out of the box ideas, and I'd love for us to build this system and get some testing done so Draper can feel good about the guidance and control systems before we go to the moon. So we appreciate it. Thanks, guys.
Thank you.
Thanks for having us. It was
That's
fun.
great. Well, thank you.